So hey, good evening everyone. So I am Akash and this is my project. And just to make it a bit more clearer to all of you, this is the application that I've built out. And if you want, you can already try downloading this, installing it on your Android application, Android phones, and uh, do share your feedback with me as well after the event. Is it audible? Okay, okay. Hello. Yeah, sorry. So yeah, I'll just pause for a while to get this. And you can go to my website also. There's a post which talks about this APK's link as well. So yeah, so let's just get started. Yeah, sorry. So yeah, on the Hasgeek submissions page itself, you can find the details about this project, the APK, the slides that I'm talking about, and other content around this, including the GitHub repo as well, which is linked here. So yeah, let's get started. So a little bit about me. So I'm a senior ML engineer at Airtel. So we do have a small office here in Indiranagar, and I'm part of their unstructured deep learning team. And my work on a day-to-day basis involves audio, speech, specifically transcriptions, summarizing them on customer care calls, as well as a lot of CPaaS-based solutions around them. And this specific project is a total tangential thing for me usually, and that is why I want to participate in this hackathon. So as you may have seen the other demos that were showcased here, most of them were around like training models, covering different languages, and let's say making models a bit more indic in nature. And my project kind of is a detraction from that. It's more of, now that you have these models, where do you run them? So the title again, which you might say is quite weird, hole in your palm, is basically trying to say that this phone that you have, this is equivalent to an EC2 instance, which may cost between, let's say, $50 a month to $90 or $100 a month, which is nothing but 8 cores, 16 GB of RAM, and discounting storage. So you're kind of sitting on an instance in your pocket, but you don't make much of it apart from calls or social media. And another thing that I think most of you might have seen is Llama CPP project. And as part of that project, they have a section which says all of the UI that has been built using Llama CPP. And in this entire list, you might have heard about these, including this one, Olama, and a lot of weird name ones. But in this entire list, only one is for Android, which is this called CAN TV. And that again is only for consuming videos, I think. So from what I could gather from their GitHub repo. So the point being that there is a lot of momentum in this space, but sadly, Android, the whole thing being open and a lot of app support being absent is kind of weird. And the name also for this project comes from another project called Hole in the Wall. Not that restaurant, but it's a project from an MIT professor, Dr. Sugata Mitra. And there, he went and put a lot of computers in a lot of villages. So basically, he had a hole, a literal hole, and he put a computer with a keyboard, and all the kids in the village could go and access it. They could search, they could read upon things. And as all teens or like school kids, they found a lot of stuff, they read a lot, and they improved their cognition for their specific grade. So what he found that basically the kids who had access to such a device in their village performed better compared to their previous years and compared to peers who did not have the same technology. And what I'm trying to propose here is basically an Android app which kind of negates the need for a GPU. So I'm not trying to say that you don't need GPUs to run these models, but what I'm trying to get to is to make a lot of LLM-based applications, you don't necessarily need 4090s or what is that, B100 GPUs per se. So yeah, so recently you might have seen, I think Ravi Teja had put this model called Navrasa. And in that, he basically had, I think he LoRa fine-tuned the model, and he had hosted the first version without the GGF files. So I went about converting it to GGF, which is a format to run on Llama CPP framework. And I got it running on Termux. And with Termux, you might have seen a lot of people install it on their phones, run the LLM on their phone, and then showcase that, okay, I can run this LLM on my phone without internet or without needing a GPU. But this entire UI of typing in a terminal does not make sense. You cannot keep going to it every time you want to experiment with an LLM. So that is why this project exists. And what this project is, it's not just, let's say, you could say everything is a wrapper, but this is a genuine wrapper around llama.cpp. And primarily, I integrate native development kit for Android along with the SDK. So in my past, you could say, prior to doing ML work, I was basically a full stack dev. And the last time I touched Android NDK was to use OpenCV. And in that again was a nightmare. And at least now it's a bit better. And with Android SDK, now that I revisit this again, instead of Java, it's Kotlin. Instead of XML, it's Compose. So it's a learning curve for everybody, basically. And the only thing that is familiar to me, coming from a typical ML background, is Hugging Face. So this project kind of marries all three together. And on the right, you can see the UI. Basically, it's a simple UI where you select the model. It shows you how much RAM you have if you have downloaded the model, and load it up. And I asked it, what's the meaning of life? And it gives you a specific answer to it. So yeah, the code is very simple. It's basically, so this CMake file here, it basically pulls the latest Llama CVP code. I then build it as a library. And you see this Llama Android module. So this is basically the interface so that Kotlin can invoke Llama CVP functions. And my app has literally 4 files. This is the main activity. This is the view. This is utilities for the LLM, which is again, these two are from the Llama CVP repo. And yeah, I'll just jump into the demo right away. So yeah, so this demo doesn't need voiceover. I just voice over myself. So you can see I opened up the app, and now, yeah. And while I'm showing this, obviously you can go to my site and fetch the APK to try it out yourself. So what I'm doing here is basically, I've downloaded the stable LM model. So the top right, you can see that model. So it's, I don't know if it's visible, stable LM, 1.6 billion. So it's a fine tune of that model from Stability AI. And that is basically fine tuned on multi-turn conversation. And it can hold a conversation, but it kind of goes off track like, occasionally. And you can see here the quantization, it's a Q4 quantize model. And it's all available on Hugging Face as well. And, sorry. So yeah, so the same question I had in the screenshot before. Previous one was meaning of life, and it gave me an answer. And here you can see the answer in the previous shot was different because I added a question mark here, and the previous one did not have this question mark. So it didn't go about finishing that, it just gave me the answer right away. And on the right-hand side, so I have loaded stable code. So that's another model from Stability AI, which is, I think, 3 point something billion parameter model. And it's specifically around coding. So it can do fill in the blanks, or NLP to do code tasks, basically a copilot which runs on your Android device, basically. And yeah, so the roadmap. So roadmap on this sort of projects is very, you could say, end user dependent. As in, if the users use it, then you go about building more features. But for this, I think the last time I met Sumod, basically he highlighted that hackathons basically are a way that people make projects and they forget about it. So that hit me very hard because I participated in a lot of hackathons, and that was generally true for the most part. So what I wanted to do here was, this is something I generally needed. Like a lot of you also might need, like if you see a model and you want to use it, you don't want to like go to Hugging Face, get a GPU, and then try to run that. It's a whole process in itself. So you have something on your, let's say, pocket or in your palm, and you should be able to run it. So using Termux itself, I'm able to get around 10 tokens per second. And this is again only on CPU, that too an emulated shell. So that means that going along, let's say into the future, if I add support for, let's say, OpenCL, and that basically is able to use the GPU that you have in your device, that means that this is always bound to go up. And as with newer hardware that comes about, and clock speeds, and as well as silicon efficiency, this is going to probably be around like 20 to 30 tokens per second, I would say, within a year or two. So that is one of the components. And I think, yeah, modality as well. So there are smaller models which do VLM or vision language models as well. And those also need support, but I haven't worked on that as such. And I think, yeah, the main point here is to be able to distribute this. Obviously, installing a sketchy APK is not the best way. So I have gone about creating an Indus App Store account. I put this there, but I think, yeah, so I did it yesterday. So yeah, so probably because of the leaves or something, it's not approved yet, but if it gets approved, I will publish it like at a wider audience as well. And I especially want to thank Bharat and Akshubhya for their guidance and support to the entire community. I got to meet Nilesh in person after 7 years on Twitter, and a lot of people as well, including Shashank, and I think Korean as well. So such interactions help, let's say, move out of the corporate deployments for AI or in general software development, and that is something which is, I would say, very cool about a community as such, and I hope to keep working on this as such. Thank you.
Yeah, so from what I understand is that we are trying to replace the need of continuous internet access with a information store in form of an LLM. Is that correct?
It is in part. So I'm not trying to replace the part where, let's say, you have new information. So obviously, new information will keep coming in every day.
Yeah.
That means, let's say you have a checkpoint. So even as humans, you may not know something, I may not know something which happened, let's say, last month. But by talking to others or by updating myself, I get to know, okay, last month this happened somewhere. So the point remains that it's more of an accessibility thing. Like if you don't have a compute, but you can start experimenting with it on your device, that means my objective is.
Also, one thing about it, so let's say like a big part of LLMs is context, right? And maintaining the track of a conversation, right? And in a lot of cases, a huge cache will build up for that. So is that a consideration that has been taken up for a device, like such a mobile device?
This APK that you fetch right now, this I think right now has 100 tokens ka output limit that I've set as of now to make the experience a bit better and not to trail with periods or something like that.
So it will flush the cache
so
after
you can do that. Like you can configure it and you can set it up how much time to use. All of that is configurable. So it's basically Llama CPP. All of the parameters are available. You just need to build an Android app. That's the only ask.
All right.
So the code is there. You can build it in Android Studio.
There was another app I think is more standard, which is called MLC Chat.
Yeah. It's the Apache. I think it's a foundation group project.
I didn't see it mentioned on your list, maybe.
It's not in the Llama CPP project as well, because the way they quantize is a bit different than how Llama CPP.
So that was going to be my question. Like they convert the model into a different format. Is there a reason why that's happening? Because that seems to be built for like Android. And
I know that. So it's called TVM or something.
I can't remember. But it's a different format.
Yeah. So I think they are, a bit more. You could say not in the way that this Garganov guy is building out projects. They're looking at a very long-term picture. So if you see, even for GPU models, when you have int4, you have variants. So you have activation-aware quantization, and you have GPT-Q as well. And so those are basically things I think right now this project doesn't focus on, Llama CPP. They're just on bare bones, just take the model, run it. Because if you think about it, if you get a new model, you'll have to do that once, that process to convert it. Whereas GGUF is like, you just need RAM to do that and you're on your way. So that is one way in which that project kind of differs. But I think if they merge, if they're able to get bigger models running on device. So I asked this question to Sayak Paul also. So he is the diffusers maintainer for Hugging Face. So I asked him, not LLM specifically, but I asked him why Stable Diffusion is not on Android like as much as iOS or macOS surprisingly is getting support. So he said initially it was because of Protobuf having a 4 GB limit or something for the weights. But then now, since this project has come out of out of the universe, but that means that you can do bigger models on device, provided you are able to quantize and convert. So Karpati also is one person who you can look up to convert models, but yeah, that is a way forward to eventually merge such approaches. No, to add support for that quantization into GGML basically.
So yeah, very interesting project. So maybe to summarize, you wrote a small wrapper in the NDK layer and also the original Llama CPP code. Plus you wrote your SDK with some basic UI and layer to interact with JNI through JNI to NDK. And now questions for you is, what are other things that you think What are use cases people want to do, especially given that you have output limit in terms of how much can you generate because of the memory, one, and second also in terms of compute itself, right? Because you only have so much of compute really on your phone. So
like off the top of my head, summarization is one.
Okay.
So at work as well, so we summarize calls. Like,
Okay.
Let's say 5-minute long calls. So it
Got
will
it,
get it into a paragraph worth of text, which means your input context is more important there as opposed to your output that is coming.
Got
and
it, okay.
Summarization usually has a 20x compression that you can do. If
Got
you go
it,
beyond
okay.
that, you lose stuff.
Got it.
The other is NER on device. So if somebody is trying to pull out or automate OCR scans or any random piece of text.
One thing I can think of is like, I mean, it's very hard to do properly, but given especially if you're in many WhatsApp groups, given a bunch of messages since you last read it, can you just summarize it for me, right? Exactly. That will be a very useful use case.
So that's the beauty, like it runs on your phone. So.
Because all of us have this problem, right? I mean, that group, okay, now I'm not touching it because it's been just too long and I need like, half an hour to read it now, right?
There's people who don't add to you, so then you have to go.
Yeah, exactly, right? So then you have to go through and read every line by line. So there are a whole bunch of use cases I can think of which are in those kind of mechanisms, but I don't think there's a good way. At least WhatsApp provides a API by which you can get only the latest.
You just export it and then do it.
Yeah, that's a tricky, still painful process. But that'll be one useful thing. The other is, I mean, how far do you think GPUs on this one? I mean, imagine a world where you get access to GPU, internal GPU calls, right? On specific phones at least. Okay, imagine you have got Qualcomm GPUs or whatever, right? In those cases, how much do you think your improvement could be? I mean, is that drastic?
So I checked out, so my phone's Adreno, whatever GPU, so it doesn't have a lot of compute cores. I mean, every manufacturer has a different logic to.
And assume the bigger,
so I think
flagship phones, right?
Expect anywhere at least 50% of what is there right now. I'm not saying it will become 100 or 200. At least 20-30 is the ballpark.
Okay, 20-30%.
Tokens per second. So.
Okay. Oh, I see. Okay. So
and that is again for a 2 billion, 3 billion
2-3x
model. Yeah,
okay, got it. Okay. So you're saying it will be maybe usable to some degree on GPUs.
So iOS it's splendid, but
so
Android
what do you need now? What do you need to get you to do some of those things? Is it knowledge of how the GPU, internal GPUs, etc.? Is that the problem?
So that part, basically Vulkan is one approach, but I think Vulkan on Android itself is not that greatly supported.
Difficult,
So the only thing we're left with is OpenCL, and OpenCL has decent support, but again you have to check for the architecture, which device it is. So I couldn't get to work on, I think, some Snapdragon variant that I had. So I had 2 devices, I tried it. Finally, this one worked, and I'm able to say with confidence that if you try this, it should work on your phone. But this is again only CPU. So OpenCL will have a lot of problems, but I think Android has support for farm testing and all. So you can check a lot of variants of devices and formally verify whether it works at a larger scale.
Got it. Thanks. A very interesting project.